right, Chapter 5 is where we're headed. And Chapter 5 is all about quadratic functions. So you have a little experience from quadratics, from algebra, and a little from geometry as well. So hopefully that will be good information to carry over and use here. So you can see our learning goals. We're going to be able to define, identify, and graph quadratic functions, and multiply linear binomials to produce quadratic expressions. That's what we're heading towards here. So first question would be, look at these expressions or equations. They should all look familiar. We've actually even practiced the squares earlier this year. This should look familiar. And we talked about a process you use from Algebra 1 because most of you were leaving out the middle term. The infamous wrong answer was x squared plus 16. The infamous wrong answer to 2x plus 5 was 4x squared plus 25. And in both cases, what we found out is that you were leaving out a middle term, whole another piece to the puzzle, so to speak. This should look like our shortest form of a quadratic equation that we can get. And we're going to be talking about what they look like, how do you graph them. So let's get started. If we want to look at standard form, we've done this of a line already, so now don't get them confused. This is standard form of a quadratic. What are you thinking of? Because you've seen this before. In one variable, standard form would be ax squared plus bx plus c, a typical trinomial, where a is the number in front of the squared term, b is the number in front of the first degree term, and c is the number that stands by itself. A, B, and C will be numbers. They could be whole numbers, they could be fractions, they could be decimals, or a combination. Now that's the combination, standard form of a quadratic, that you worked with the most in algebra and geometry. There is another one I'd just like to introduce to you right now. And it's called, what if we do it in two variables? So look at this one. Ax squared plus bxy plus cy squared plus dx plus e plus f. If we gave you two variables, we'd have a little more to multiply out. But what I want you to look at is our usual conversation goes something like this. Up on top, and in degree 1, you can look at, I said in degree 1, in one variable, we have 3 different terms that all have different degrees on them. And when we talk about degrees, we're usually talking about degree of the variable. So on the ax squared term, our degree is 2. The variable is x. On our bx term, the degree is 1. Our variable is x. And on our c term, the variable is 0. And our degree is 0, and our variable is non-existent. It doesn't have one. It has a number. It's called a constant. So on this one, if we look at it, in 2 degrees, we have a degree here. We have degrees here, 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 and then again if we'd say 0, but it has no degree because it has no variable in it. It's the only term that does not have a variable. Each of them have a degree, and when we like to say we have something in standard form, we like to say it's in order by degree. So on our one variable lookup, we were saying it went from second degree down to first, which was understood, down to 0 because we had no x to the 0 term. It wasn't there. Down here we have second degree. We have a second degree on the c y squared term. We have a first degree understood on the dx term. We have a first degree understood on the ey term. And we have that same characteristic of f. It has no variable in it. So therefore it's a constant, degree 0. The only term that's sort of left in question is this bxy term. Look at it. The x really has a 1 sitting on it. The y really has a 1 sitting on it. So believe it or not, this is of degree 2 also. So it is in order when we talk about, second degree terms. Squared, 2, squared, 1, 1. And it's also in order when we talk about alphabetical order. X squared comes before x to the first, y to the first, which comes before y to the second, because an x precedes or trumps a y. So look carefully. We're not going to have a ton of these two variable quadratics, but they are going to be out there every once in a while floating around, and you're definitely going to see them on some of your standardized tests. All right, standard form of a quadratic. Because we have seen some of these shortcuts before, instead of using FOIL every single time, we want to try to convince you that you can actually use something else called the binomial square theorem. The binomial square theorem is a 3-step process compared to FOIL, F-O-I-L, first, outside, inside, last, is a 4-step process plus collect like terms and simplify. This is 3 steps and done. You're writing your answer as you go. So let's notice right away that in a binomial, x plus y quantity squared, so there's our first, or the second one, x minus y quantity squared, you have some similarities. If I would FOIL this out, x plus y times x plus y, I would get x squared plus 2xy plus y squared after I finished all the combining like terms. X minus y quantity squared, same thing. If I FOILed it out, collected all the like terms, I would get x squared minus 2xy plus y squared. So start looking. Let's draw some parallels. The first terms are identical. The middle terms are identical with the exception of their sign. The third or last term is identical. So, when we like to say, how are we going to remember in a shorter form this binomial square theorem? We like to say it comes from the binomial. So don't think of, I'm going to write x plus y times x plus y each time. We want you to think there's only one of them, and we're going to go through the process and try to eliminate and square, as it says. And if we do that, we should be able to look at just this quantity. In doing so, here are the shortcut rules we'd like you to follow. Think of it as square the first term. Well, in this problem, that first term is an x, so if I squared that first term, I get x squared. Next step, take the product of the two terms and double it. Well, your two terms are your x and y. If you multiply x times y, you get xy. If you double anything, you times it by 2. So, 2xy. And last but not least, you would square the last term, in this case the y, and we would get y squared. So you can see the only thing that's going to have any bearing on the binomial square theorem is the sign in your quantity to begin with, because everything matches exactly with the exception of the plus or minus sign on that middle term. It's always a minus when your quantity is a minus. It's always a plus when your quantity is a plus. So notice, it is shorter. It's 3 steps. There's no collecting like terms. This is your answer. So let's reset this page and let's just try it on a couple. So let's do a fairly simple one to start with. X plus 5, the quantity squared. Square the first. Take the product of the two and double it. Square the last. Didn't do any extra combining, nothing. You're done. Let's do something a little tougher. So my quantity now is 3 minus 2x, and it's the quantity squared. I'm not going to rearrange in my head the order. There's only 2 terms. I'm going to leave it as it is. If I have to rearrange, I could always do that as my last step. So here we go. Square the first. Take the product of the 2, doubled. Square the last. You don't like it in standard form? Then rewrite it. Final answer, 4x squared minus 12x plus 9. So 3 steps, no rewriting unless it's out of order. Binomial square theorem. So when we start exploring quadratic functions, and we know we're dealing with the basic equation y equals kx squared, where k can vary, we should know that all of these things graph into a parabola. Obviously, if k is greater than 0, opens up. If k is less than 0, it opens down. We want you to start thinking about characteristics like that, because one of our goals is we're going to make a list here at the end of our lesson today. Axis of symmetry. Think about your parabolas. Every single parabola that you draw that goes through 0, 0, nice, has that line of symmetry that cuts your graph in half. Standard form we just talked about, a vertex. Every one of these parabola has a vertex. That vertex can also be considered either its minimum or maximum value, depending upon the k value to start with. So there's some characteristics you should be familiar with about our parabolas, our quadratics, and how they're going to move on this x and y coordinate plane. Look at these, a little bit about symmetry from geometry. You can draw a line of symmetry through each object. So if you would, write your maximum that you can draw. And you can just draw a quick sketch or just draw what the shape was and write your number. We're going to check on these when we come to class as part of our discussion. Symmetry. Next is that list that I was referring to. And you have characteristics of the equation y equals ax squared plus bx plus c, our standard form of a parabola. We know that every single one of them graph into a parabola. We know that that a value determines whether it opens up or down. There are still other characteristics that you could list. So continue your list. What's number 3? What's number 4? Be specific as possible and come with a list, and we will see how it compares, or we will make a list that's cumulative with everybody's ideas together. So we have a thorough list of characteristics of any equation in the form y equals ax squared plus bx plus c. So to bring those to class with you, and we should be good to go to share. Thanks.